From Cape Canaveral in Florida, this is Falcon Launch Control at T-minus 1 hour, 13 minutes, 10 seconds and counting. The countdown is on schedule for the launch of the SpaceX CRS-8 Falcon 9 rocket with the Dragon capsule bound for a rendezvous with the International Space Station. The Dragon capsule on this flight will transport more than 7,000 pounds of cargo, including 250 science experiments, crew supplies, and flight hardware for the space station. Launch is targeted for liftoff at 4:43 p.m. this afternoon. The pre-launch activities, which have been underway, have recently included a verification check with the Air Force Eastern Range tracking stations here at Cape Canaveral and downrange, and the NASA Tracking and Data Relay Satellite System. The Air Force Range Safety Whole Fire checks have been completed. This is the ability of the Range Safety Range Control Officer to hold the launch at any time before launch if necessary. The Flight Termination System checks with the Eastern Range for after liftoff have also been completed. Upcoming at T-minus 1 hour will be a weather briefing from the Air Force Launch Weather Officer. A readiness poll of the launch team will be conducted at T-minus 38 minutes, followed by loading the rocket with liquid oxygen and RP-1 fuel, which will begin at T-minus 35 minutes before launch. Also, 10 minutes before launch, the rocket's engines will receive their final liquid oxygen chill down for flight. At T-minus 2 minutes, the Air Force Eastern Range gives a go for launch. And then finally, at T-minus 90 seconds, the SpaceX launch director gives a go for launch. At this time, weather continues to look favorable. We're not working any problems in this countdown, and we are on schedule for a launch at 4:43 this afternoon. At T-minus 1 hour, 11 minutes, 13 seconds and counting, this is Falcon Launch Control. This is Falcon Launch Control, T-minus 1 hour, 8 minutes, 40 seconds and counting. Joining us now here in the Mission Director Center is Dr. Howard Levine, Chief Scientist for the Utilization and Life Sciences Office at the Kennedy Space Center. Dr. Levine is going to tell us something about the life science objectives for this particular SpaceX CRS-8 mission. Dr. Levine, welcome, and thank you for joining us. And I wonder if maybe right off you could tell us, why does NASA conduct animal research? Can we really learn something from studying mice?
Well, definitely. There's two basic objectives in doing these kinds of research. Number one is to mitigate risk for the crew on long-duration spaceflight missions. I think, as most people know these days, there's a number of detrimental effects of spaceflight. So we use mice as model systems to study these and to try and come up with countermeasures to mitigate the risks. The second reason we do this is essentially to benefit life on Earth. Many of the things that we learn through these studies are very useful for mitigating different kinds of diseases and detrimental effects of bed rest, for instance, or cancer drugs on Earth. So there's both a spaceflight application and an Earth application.
Well, for what biomedical problems encountered in space can animals be used?
Well, there's a number of them, but the three major ones that people often talk about is the loss of muscle mass, the loss of bone mass, and the compromising of the immune system. So for the first two, it really goes down to the use it or lose it phrase. And since the astronauts are floating around, they're not using their muscles or their bones. So they tend to degrade and decrease during the course of a spaceflight experiment.
What's the objective of this Rodent Research 3 spaceflight experiment?
So I think there's a picture that we can put up. So what you see here on the left is the rodent habitat. Two of these will be flown to the International Space Station. In the center is the transporter unit. This will be transporting the mice up to the International Space Station, after which they will be transferred to the habitats. And the unit on the right is called the Animal Access Unit. It is placed on top of the transporter and used to remove the mice and transfer them to the rodent habitats. But getting to your question, the basic objective is to study muscle degradation, muscle atrophy over time during the spaceflight experiment, and also to test a new potential countermeasure to that, which is the use of a muscle degradation injection that will be given to the mice prior to liftoff and also during the launch. And this is supposed to interfere with the degradation of the muscle over time.
For this experiment, how many mice are being used on this flight?
So each of the rodent habitats will contain 10 mice. So that's 10 in one, 10 in the other. So that's 20 mice will be flown up to the International Space Station. In addition, there's 10 vivarium control mice. And then there's another 10 plus 10 mice that will be used as ground controls at the Kennedy Space Center. And then there's probably about another 40 mice that are backups in the event that there's something wrong with some of the mice or their weight is out of spec. We try and keep them all within a well-defined weight range to reduce variability. Sometimes certain mice become aggressive and they pick on the other mice, so that they have to be deselected and replaced with other mice. So in total, there's about 90 mice involved with each launch attempt.
You touched on this briefly. What, if anything, is done to the mice prior to the flight?
So the first thing that's done is they get a little microchip that's inserted just below the skin so that you can identify them. It's similar to what you would have in your dogs. When they arrive at Kennedy Space Center, they're allowed to acclimate for about 3 days. Then they're assessed for, essentially for sterility. Samples are taken to make sure that they don't contain pathogens that could affect the crew on the International Space Station. They are then put into cages and they are assessed for their sociability, okay, whether they get along with each other. They have to be acclimated to the grids that are within the cages, which are similar to what they will have in the rodent habitat, that will allow them to grab onto all sides of the rodent habitat, make full use of the space. They also have to acclimate to the food bars, which is a different kind of food, and to the water delivery system. Then, at a certain point in time, they are assessed for their strength in their front limbs. There's what's called a grip test, where they hold on to a grid and they're pulled back, and the point at which they let go is a measure of the strength of their forearms. So that's done. And then they receive the injection prior to launch. They get loaded up into the transporter and brought out to the launch pad.
Now, what happens if for some reason the launch gets postponed till tomorrow or, sometime after that?
Mm-hmm. So the transporter, it's brought out, it's inserted into the Dragon capsule, and that happens 18 to 24 hours before launch. And if launch is scrubbed, it stays within the Dragon capsule for, let's say, another 24 hours for a second launch attempt. So you can get really 2 successive days of launch attempts. And if it doesn't go on the second day, then it's brought back and refurbished and sent out again at the next launch opportunity.
Well, Dr. Levine, thank you very much. We appreciate your explaining how these mice will be applicable to longer-term uses for life science in space and to humans in space. And thank you so much for coming by and talking with us.
Well, it was my pleasure.
And we're now at T-minus 1 hour, 54 minutes and counting. This is Falcon Launch Control.
It was live. All right, thank you.
This is Falcon Launch Control at T-minus 1 hour, 1 hour, 23 seconds and counting, remaining to our liftoff of the SpaceX Falcon 9 rocket. In about 15 seconds, we're going to be hearing Captain Laura Godoy from the Air Force 45th Weather Squadron giving us a weather briefing.
Hello on CC Local and Weather Brief with your L-minus 1 hour weather briefing. Taking a look at the satellite image, you can see the jet streak streaking across central Florida, bringing in some more moisture overhead. The low-level stratocumulus clouds over the first stage recovery area is pushing out into the Atlantic. Taking a look on the visible satellite imagery, again, you can see the upper-level clouds pushing overhead, as well as some contrails developing in that moisture. There is very few cumulus cloud development, none around the launch complex. The fire previously seen 20 nautical miles west of the pad is pulsing now and becoming weaker. The track of the smoke plume is tracking north of the complex now as our winds have switched to be more west-southwesterly. Our latest upper-level wind data is not decreasing the winds significantly like expected. However, that is because the balloon is tracking downstream. We do expect overhead that our upper-level winds are about 10 knots lighter at 45,000 feet. Winds at the surface around the launch complex have been picking up as expected. We're seeing gusts to 25, 26 miles per hour, and wind direction is switching to be from the southwest again. The southerly sea breeze has toggled back and been taken over by the predominant southwesterly flow. We expect by T0 the wind direction to be from 250. We are not concerned with any solar weather as the Proton's flux has stayed constant. We are go for all launch commit criteria. That's all range and user criteria. The launch forecast calls for just few cirrus clouds at 25,000 feet. Winds will be from the west-southwest, 17 gusts 22 miles per hour. And we remain less than 10% for probability of violation. For the first stage recovery, we're expecting nearly clear skies with wave heights only 4 to 6 feet. Wave directions are from the west, and wind speeds remain really similar to what we're observing here at the Cape. Overnight, we're expecting the winds to trend upwards, gusting to about 27 miles per hour at the launch complex, and that would be peaking at midnight and trending downwards on Saturday. We are not expecting any rain or lightning on the complex over the next 24 hours. In the event of a 24-hour delay, we're expecting few cumulus clouds to develop. However, we're not expecting significant vertical extent on that. That is why we're going with a 10% probability of violation on Saturday. And winds will be from 030 due to a weak sea breeze setting up, and they'll be a little bit lighter than we're seeing today. This concludes my briefing, unless there are any questions.
Weather briefing is complete from Air Force Captain Laura Godoy. As we heard, we have a very good chance of launch today. Peak winds no more than 20 miles per hour, temperature of about 75 degrees, 20% cloud cover overhead, and only a 10% chance of not meeting our launch weather criteria, which are primarily due to liftoff winds. At T-minus 55 minutes, 30 seconds and counting, this is Falcon Launch Control. This is Falcon Launch Control, T-minus 53 minutes, 37 seconds and counting. We're being joined now by Joy Amasa, the NASA Veggie science team lead for Veg-03, flying on this SpaceX mission from the Kennedy Space Center. And Joy, perhaps you can lead off by telling us a little bit about what we learned so far about how plants grow differently in space.
Well, so we've grown 3 crops in Veggie in the Veggie-1 validation tests, and so we grew 2 crops of the red romaine lettuce, and we've only gotten samples back from one of those crops so far, but they actually grew pretty similar to our ground control lettuce. So we were really happy about that, and that also helped provide us enough data that for the second crop, the crew were actually able to eat the lettuce that they grew. We will be getting some samples back on that lettuce when this SpaceX 8 rocket returns from space station. So we're looking forward to those samples, so we'll be able to really do a good analysis of those. We also grew the zinnias on space on the space station, and Scott Kelly harvested those on Valentine's Day, and they grew also very well. So we'll look forward to getting some of the samples of those flowers back as well. And so for Veg-03, we're going to add a new crop. That's going to be the Tokyo Bacana Chinese cabbage. We have some seeds of that here. It's a little hard to see. They're little tiny round balls. And so we're sending those along with some more of the outrageous lettuce seeds that we sent before.
Well, tell us a little bit how the astronaut role in Veg-3 will be different for this mission than it may have been for the others.
That's a great question, George. One of the things that we're working on adding that we added to the zinnias was autonomous gardening. And so we're looking at having the crew really take ownership of the plants that they're growing. And so they will figure out how much water to add and when to do the other operations. We're giving them some guidelines for that. And, you know, we think that we really want them to be able to be really actively involved in the gardening process, not just dependent on all the instructions from the ground, because they're the ones who are seeing the plants so that they can respond to the needs of those plants.
So their role, once they get our cargo from the Dragon, what will they have to do to get these plants started?
So we're sending the plants up in plant pillows. These are dried kind of grow bags. We have them filled with a media, which is a baked ceramic substrate. It's kind of like a kitty litter almost, but it's a porous ceramic media. It's the same material that's used on baseball fields and golf courses. And in that media, we also have a controlled release polymer fertilizer that will slowly release the nutrients that the plants need. Everything is sent up dry, and the seeds are planted in these little wicks that are right here in the plant pillows. And they're glued in there, so they're in these gas impermeable bags. They're kind of a crinkly bag, and they'll keep the seeds really fresh for a long time. So the astronauts will unload the Veg-03 plant pillows, and they'll stow them. And then when there's an opportunity to grow these plants, they'll add water. And these plant pillows, they have kind of a water tube that injects water in a ring inside. And that ring's embedded in that substrate, that porous media. And so they'll add water and insert them into the Veggie system, turn on the lights, and prepare to grow a garden. So both of these crops, the Chinese cabbage and the red romaine lettuce, will grow for about a month. And we're working on getting the approval for the crew to eat the Chinese cabbage. We already have the approval for them to eat the red romaine lettuce. So we'll still bring some of the plant samples back to Earth on a future SpaceX mission probably, so they'll be stored in the freezer until then, so we can just check and compare with our ground control plants.
Well, Joy, thank you very much.
Thank you, George.
Joy Massa, our NASA Veggie Science Team Lead for Veg-03 from the Kennedy Space Center.
Thank you.
And we're now at T-minus 49 minutes and counting. This is Falcon Launch Control. This is Falcon Launch Control, T-minus 47 minutes, 36 seconds and counting. Everything continues on schedule for a launch at 4:43. Standing by to get ready shortly to go into our propellant loading activities. We're not working any issues that would constrain starting that right on time. One of the largest experiments aboard Dragon flying into space inside the unpressurized part of the Bigelow Expandable, or rather the Dragon capsule, is the Bigelow Expandable Activity Module. This was privately developed by Bigelow Aerospace. It's a 3,100-pound module that does not have rigid, heavy side panels, but instead it's made of a thick material to safely hold air inside while being strong enough to resist any micrometeoroid damage. Once mounted to the space station, as its name implies, it will be expanded to a length of 13 feet with a 10.5-foot diameter width, about 4 times its packed volume inside the Dragon. The interior will then have 565 cubic feet of available space. This flight is meant to determine whether the concept offers designers a way to build modules that expand after launch to create much larger habitable spacecraft for deep space missions, such as for the journey to Mars. We're now at T-minus 45 minutes, 56 seconds and counting. We'll have preps to begin loading propellant at T-minus 38 minutes. We'll have a poll, and then at 35 minutes, initiate our launch automatic sequence to begin the RP-1 and LOX loading. So that puts us now very close to that, coming up here in about 7 or 8 minutes. We're at T-minus 45 minutes, 26 seconds and counting. This is Falcon Launch Control.
OSM LC countdown net.
OSM.
Verify the BDA is clear and the flight hazard area roadblocks are established.
BD is clear and the flight hazard area roadblocks are established.
OSM verify go for propellant load.
Go for propellant load.
This is Falcon Launch Control, T-minus 43 minutes, 30 seconds and counting. We see the Falcon 9 rocket live out on the pad. Preparations now underway to begin the propellant loading sequence, which will start at T-minus 35 minutes. We'll have a poll of the team before that. Here's an animation of the Falcon 9 rocket as it's prepared for launch, raised to vertical. This is the 8th contracted cargo resupply mission for SpaceX. It'll carry 6,913 pounds of cargo to the space station. And very importantly, it will deliver the Bigelow Expandable activity module that we've just seen. Completely clear skies here at the launch site. In about 4 minutes, we should have our launch readiness poll for the fueling. At T-minus 42 minutes and counting, this is Falcon Launch Control. This is Falcon Launch Control, T-minus 40 minutes, 47 seconds and counting. After liftoff from Complex 40, Dragon will begin its journey to the space station. Just after 10 minutes after the launch, the capsule will reach its preliminary orbit, deploy its solar arrays, and begin a very carefully choreographed series of engine firings to rendezvous with the International Space Station. With the launch today, the rendezvous and grapple with the ISS will occur on Sunday, April 10th at 7 a.m. Eastern Time. At the time of launch today, the International Space Station will be an altitude of 250 miles over northwestern Iraq. Upon return, the splashdown in the Pacific is planned for May 11th at 11:56 a.m. West Coast time, 227 nautical miles from the coastline of Southern California. Dragon will be bringing home 1.5 tons of cargo and research experiments from the space station. Standing by now here for our readiness poll to begin our fueling of the Falcon 9 rocket. At T-minus 39 minutes, 37 seconds and counting, this is Falcon Launch Control.
All stations verify go for launch. All stations acknowledge. Prop.
Prop go.
AVI.
AVI go.
GNC.
GNC go.
Recovery.
Recoveries go.
Ground.
Ground is go.
VC.
VC go.
GC.
GC's go.
RC.
RC go.
OSM.
OSM go.
ROC.
Rock is go.
CE.
CE is go.
MD.
MD's go.
LD, verify go to initiate propellant load.
Go to initiate propellant load.
VCDC, start your launch auto sequences set to start at T-minus 35 minutes.
Copy. Launch auto is queued. Waiting on T-minus 35 minute trigger.
Before T-minus 30 seconds, any no-go condition shall be immediately briefed to the LD or CE for resolution without a hold being called. Hail LD or CE on launch vehicle net. Say no-go, recommend hold, and brief the anomaly immediately. LD or CE will finalize stopping the launch countdown. At T-minus 30 seconds or later, indicate an urgent need to abort the launch auto sequence with high risk of imminent hardware damage by saying hold, hold, hold on the primary countdown net. The VC will abort the auto sequence immediately. If a hold is called, all operators proceed to the launch abort steps in 10.57. Falcon 9 tanks are vented for propellant load. Attention all personnel, stand by to pick up the count. T-minus 35 minutes and counting on my mark. Three, two, one, mark. VCDC, announce your launch auto sequences have started.
F9 launch auto sequence has started.
Dragon terminal count has started.
OSM, set launch enable to flight.
Flight.
Stage 1, Stage 2 DP's tracking. Stage 1 locks DP tracking. Stage 1, Stage 2, fuel flow rates. Right on target.
This is Falcon Launch Control, T-minus 32 minutes, 22 seconds, and counting. Fuel and liquid oxygen flowing into the SpaceX Falcon 9 rocket. Flow rates are nominal. Length of the Falcon 9 rocket, 229 feet with a diameter of 12 feet. It has 9 Merlin engines, 1D engines that provide a thrust of 1.53 million pounds. This rocket was fully designed and built by SpaceX. It's named for the Millennium Falcon in the Star Wars movies. The number 9 refers to the 9 Merlin engines that power the Falcon 9's first stage. The Falcon 9 is designed to carry both commercial and government satellites, as well as SpaceX Dragon cargo with supplies, and eventually up to 4 astronauts up to the International Space Station as part of the commercial crew program. After liftoff from Complex 40, tracking stations from around the world will track the Falcon 9 into orbit, including SpaceX and Air Force ground stations at Cape Canaveral Air Force Station and Kennedy Space Center, Jupiter Inlet in South Florida, downrange at Bermuda, in Newfoundland and Oathanger, England, and also at Air Force stations located in New Hampshire and on the island of Diego Garcia in the Indian Ocean. Once in orbit, Dragon will also have a direct link through NASA's tracking and data relay satellite system throughout all of its remaining activities leading up to grapple with the space station. At T-minus 30 minutes, 30 seconds, and counting, this is Falcon Launch Control.
T-minus 30 minutes.
Initializing Stage 1 helium cushion.
This is Falcon Launch Control, T-minus 28 minutes, 5 seconds, and counting. This is the Dragon module that SpaceX is providing for NASA cargo, 6,913 pounds of cargo on board, half of which is the Bigelow expandable module. Dragon has a diameter of 12 feet. It's 23.6 feet in length. And, of course, its primary mission is the resupply of the International Space Station. About 10 minutes after launch, Dragon reaches its preliminary orbit. It then deploys its solar arrays and begins a carefully choreographed series of thruster firings to reach the space station. After a 2-day trip, NASA astronaut Jeff Williams and ESA astronaut Tim Peake will use the station's 57-foot robotic arm to reach out and grapple the Dragon spacecraft as they operate from the station's cupola. Ground commands will be sent from Houston for the station's arm to rotate Dragon around and install it on the ISS on the bottom side of the Harmony module. By the next day, the crew will pressurize the vestibule between the station and Dragon and will open the hatch that leads to the forward bulkhead of Dragon. Then over the next month, the crew will unload the spacecraft and reload it with cargo for return to Earth. Departure from the ISS will occur on Wednesday, May 11th. It will bring back experiments and biological samples from the flight crew, including those samples collected from the astronauts during their one-year mission. For its return, approximately 5 hours after Dragon leaves the station, Dragon will conduct its deorbit burn, which lasts about 7 to 10 minutes. It will then take approximately 30 minutes to re-enter the Earth's atmosphere and splash down on its 3 main parachutes in the Pacific Ocean, 227 nautical miles off the coast of Southern California at about 11:56 a.m. Pacific time. At T-minus 26 minutes, 5 seconds and counting, this is Falcon Launch Control.
E9 and fuel collector pre-valves closed.
All 3 liquid helium pumps are running to the rail cars.
This is Falcon Launch Control, T-minus 24 minutes, 13 seconds and counting. The International Space Station has just flown overhead of the launch complex, Pad 40 at Cape Canaveral. And after launch, the Falcon 9 with Dragon will begin its race to catch up to the space station on Sunday morning at 7 a.m. All of the fueling activities on the Dragon 9 are going well, according to schedule, and we are on time for a launch at 4:43 this afternoon. And actually, that launch, it's a 1-second launch window, and the actual liftoff time is 4:43:32 p.m. Eastern. At T-minus 23 minutes, 18 seconds and counting, this is Falcon Launch Control.
Stage 2 fuel closing up.
This is Falcon Launch Control, T-minus 20 minutes, 21 minutes, 30 seconds, and counting. This is the SpaceX Launch Control Center at Cape Canaveral Air Force Station, where the launch is being controlled from today by the SpaceX launch team, as we see here. This is the SpaceX Mission Control Center, from where the flight will be controlled from, monitored, and all of the Dragon activities, including separation from the Falcon, are being monitored and controlled for our launch today. And this is at the Johnson Space Center in Texas, the International Space and Mission Control Center, where Mission Control in Houston is also monitoring the progress of the launch today and the subsequent flight of the Dragon module after it separates from the Falcon 9 rocket. Live shot now from Complex 40 at Cape Canaveral Air Force Station at T-minus 20 minutes, 15 seconds and counting. This is Falcon Launch Control.
T-minus 20 minutes. Stage 2 liquid oxygen load set to start in 30 seconds.
Initializing Stage 2 LOX load. Stage 2 LOX DPs are tracking.
This is Falcon Launch Control, T-minus 17 minutes, 52 seconds and counting, leading toward an on-time launch at 4:43. This is the complete Falcon 9 rocket with the Dragon atop, second and first stages, length 229 feet overall, 12 feet in diameter, 9 Merlin 1D engines with 1.53 million pounds of thrust. The rocket is held down on the pad and not released for flight until all 9 engines and launch vehicle systems are confirmed to be up and burning. After the liftoff, The first stage will burn for 2.5 minutes before separating from the rest of the rocket, and then a single Merlin engine on the second stage will burn for 7 minutes 19 seconds before the second stage cuts off 10 minutes into flight. The Dragon capsule separates from the second stage 30 seconds later. After the liftoff, mission control for the Falcon 9 and Dragon spacecraft will be at the SpaceX Mission Control Center in Hawthorne, California, which we saw a live shot of SpaceX Mission Control in Hawthorne. Dragon will have a link with a series of ground tracking stations around the world and also will be using NASA's tracking and data relay satellite system. At T-minus 16 minutes, 6 seconds and counting, this is Falcon Launch Control.
Stage 1 fuel load closing out.
This is Falcon Launch Control at T-minus 14 minutes and counting, getting ready for a readiness poll of 14 console positions, followed by a readiness at T-minus 11 to start the terminal countdown auto sequence, which begins at T-minus 10 minutes. At T-minus 10 minutes, the Falcon 9 and Dragon auto sequence is started, leading us down to liftoff, and we'll also begin chilling the 9 first stage Merlin engines for launch. Shortly after that, Dragon will be going to internal power. At T-minus 13 minutes, 20 seconds and counting, this is Falcon Launch Control.
Stage 2 helium fill has started.
Stage 2 LOX load, throttling back for Stage 2 cryo-helium load. MVAC and M1D BTV heaters are up.
prop confirmed, ready for engine chill in 30 seconds.
Prop is ready for engine chill in 30 seconds. And closing out grid fin bottle fill and disabling boost back hazards. Stage 2 venting for LOX fast fill. And initializing hydraulic T-tab spin final setups.
Second stage transmitters back on.
Initializing M1D trim valve setups.
T-minus 9 minutes.
This is Falcon Launch Control, T-minus 8 minutes, 42 seconds and counting. Right now we're in the auto sequence leading down to our liftoff at 4:43. The 9 first stage Merlin engines are being chilled down. Dragon will be going internal here in about another minute or so. And that takes us down into the very end of the countdown, where we'll get our final communications checks with the Eastern Range. We'll transfer the Falcon 9 to internal power, and then about 4 minutes and 20 seconds start the strong back retract. We're now at T-minus 7 minutes, 53 seconds and counting. This is Falcon Launch Control.
Initializing MVAC FTV setup.
T-minus 7 minutes.
Stage 1, Stage 2, LOX flow rates all nominal. M1Ds reasserting to TVC null position.
T-minus 6 minutes.
Vehicles in self-align. Stage 1, Stage 2 heaters closing out.
T-minus 5 minutes.
Stage 1 helium bubble secured.
NIFCO, OSM, RCO. This is RC on countdown 1 with a comm check.
NIFCO has you loud and clear.
This is the RCO.
OSM has you loud and
I
clear.
have you loud and clear.
Copy, have all parties loud and clear, moving to range ops.
Stage 1, Stage 2 press for strong back retract.
T-minus 4 minutes.
Strong back motion has started. FTS is on internal power. FTS is armed.
VC, verify FTS is ready for launch.
FTS is ready for launch.
GNC, verify stage 2 TVC motion nominal.
GNC confirms good stage 2 TVC motion. Stage 1 launch.
This is Falcon Launch Control, T-minus 2 minutes, 36 seconds and counting. Strong back now fully retracted. Our next major call will be at T-minus 1 minute, 30 seconds when the launch director will give his final go for launch.
Stage 2 locks close up.
T-minus 2 minutes.
Falcon 9's on internal power. Vehicles in self-align.
LD, verify go for launch.
LD, go for launch. Stage 1, Stage 2, cryohelium secured for flight.
VCDC, verify Falcon 9 and Dragon are in startup.
Falcon 9's in startup.
Dragon is in startup.
Stage 1, Stage 2, pressing for flight.
T-minus 45 seconds.
T-minus 30. T-minus 20.
Falcon 9 secured at flight pressures.
T-minus 15 seconds. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Engine ignition. Liftoff of the Falcon 9 rocket with science for today and for deep space exploration tomorrow. Falcon 9 has cleared the towers.
Of course, SLW has AOS.
Vehicle now going through the sound area. Vehicle's now transonic. Through max Q.
Stage 1 propulsion is still nominal. MVAC chill has begun.
Down telemetry nominal.
Launch plus 2 minutes. First stage separation, 2 minutes and 34 seconds. Standing by for first stage separation.
Stage sep.
First stage separation confirmed. Second stage ignition.
Stage 1 is entering its flip. Dragon nose con deploy.
Fairing has been jettisoned. We can clearly see the first stage falling as the second stage continues to burn, and it will burn for the remainder of the flight till 10 minutes
Stage
into
2
the mission.
propulsion is still nominal.
This is the SpaceX Falcon 9 Mission Control Center. Telemetry is still strong.
Stage 1 boost back is starting. Stage 1 boost back is ended.
Actual liftoff time was 4:43:31.000.
Acquisition signal Bermuda.
Stage 2 propulsion is still nominal.
Stage 2 power and telemetry still nominal. We have AOS in New Hampshire.
That's the Air Force tracking station located in New Hampshire. That'll be followed by Newfoundland.
Stage 1 entry is started. Stage 1 entry is shut down. Stage 1 is transonic. Stage 1 landing burn is started. Landing legs have deployed. Of course, I still love you. We have a Falcon 9 on board. Landing operators moving to procedure 11.100 on recovery net.
FTS has been saved.
Flight of the Falcon 9 second stage continues to go nominally. As we've seen, the first stage has successfully landed on the barge in the Atlantic Ocean. As we saw, there was a lot of excitement in the SpaceX mission control in Hawthorne when it touched down.
Clear for land acquisition of signal.
35 seconds to spacecraft separation.
Failed deploy confirmed.
And we've got it. Spacecraft separation. Dragon has separated from the Falcon 9. Two milestones here today. The Falcon 9 spacecraft has had a successful ride into space.
Position at Newfoundland.
The Dragon is now on its own. Next activity will be to deploy the solar arrays in about 30 seconds. And a successful landing of the first stage offshore. And now we see the solar arrays of the Dragon deploying. Dragon flying free on its own. This is live video from the Dragon of it deploying its solar arrays. Solar arrays confirmed to have deployed at 4:59 and 1 second. This is Falcon Launch Control. Mission elapsed time is 16 minutes, 23 seconds. Next activity on NASA television will be the post-launch news conference coming up exactly 1 hour from now at 6 p.m. Eastern Time. And with that, we'll conclude our launch coverage and go to replays of the launch of the Falcon 9 with the Dragon, which occurred just about 17 minutes ago now. This is Falcon Launch Control.
T-minus 20.
Falcon 9 secured. Flight pressures.
T-minus 15 seconds. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Engine ignition. Liftoff of the Falcon 9 rocket with science for today and for deep space exploration tomorrow. Falcon 9 has cleared the towers.
SLW has AOS.
Vehicle now going through the sound area. Vehicle's now transonic. Through max Q.
Stage 1 propulsion is still nominal. MVAC chill has begun.
Downwind telemetry nominal.
Launch plus 2 minutes. First stage separation, 2 minutes and 34 seconds. Standing by for first stage separation.
Stage sep.
First stage separation confirmed. Second stage ignition.
Stage 1 is entering its flip. Dragon nose cone deploy.
Fairing has been jettisoned. We can clearly see the first stage falling as the second stage continues to burn, and it will burn for the remainder of the flight till 10 minutes into
Stage
the
2
mission.
propulsion is still nominal.
This is the SpaceX Falcon 9 Mission Control Center. Telemetry is still strong.
Stage 1 boost back is starting. Stage 1 boost back is ended.
Actual liftoff time was 4:43:31 decimal 0. Liftoff time was 4:43:31 decimal 000.
Acquisition signal Bermuda.
Stage 2 propulsion is still nominal.
Stage 2 power and telemetry still nominal. We have AOS in New Hampshire.
That's the Air Force tracking station located in New Hampshire. That'll be followed by Newfoundland.
Stage 1 entry is started. Stage 1 entry is shut down. Stage 1 is transonic. Stage 1 landing burn is started. Landing legs have deployed. Of course, I still love you. We have a Falcon 9 on board. Landing operators moving to procedure 11.100 on recovery net.
FTS has been saved.
Flight of the Falcon 9 second stage continues to go nominally. As we've seen, the first stage has successfully landed on the barge in the Atlantic Ocean. On the as we saw, there was A lot of excitement in the SpaceX Mission Control in Hawthorne when it touched down.
Newfoundland acquisition of signal.
35 seconds to spacecraft separation.
Failed deploy confirmed.
And we've got it. Spacecraft separation. Dragon has separated from the Falcon 9. Two milestones here today. The Falcon 9 spacecraft has had a successful ride into space.
Position at Newfoundland.
The Dragon is now on its own. Next activity will be to deploy the solar arrays in about 30 seconds. And a successful landing of the first stage offshore. And now we see the solar arrays of the Dragon deploying. Dragon flying free on its own. This is live video from the Dragon of it deploying its solar arrays. solar arrays confirmed to have deployed at 4:59 and 1 second.
T-minus 20.
Falcon 9 secured. Flight pressures.
T-minus 15 seconds. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Engine ignition. Liftoff of the Falcon 9 rocket with science for today and for deep space exploration tomorrow. Falcon 9 has cleared the towers.
SW has AOS.
Vehicle now going through the sound area. Vehicle's now transonic. Through max Q.
Stage 1 propulsion is still nominal. MVAC chill has begun.
Down telemetry nominal.
Launch plus 2 minutes. First stage separation, 2 minutes and 34 seconds. Standing by for first stage separation.
Stage sep.
First stage separation confirmed. Second stage ignition.
Stage 1 is entering its flip. Dragon nose cone deploy.
Fairing has been jettisoned. You can clearly see the first stage falling as the second stage continues to burn, and it will burn for the remainder of the flight till 10 minutes into
Stage
the
2
mission.
propulsion is still nominal.
This is the SpaceX Falcon 9 Mission Control Center. Telemetry still strong.
Stage back is starting. Stage 1 boost back is ended.
Actual liftoff time was 4:43:31.000.
Acquisition signal Bermuda.
Stage 2 propulsion is still nominal.
Stage 2 power and telemetry still nominal. We have AOS in New Hampshire.
That's the Air Force tracking station located in New Hampshire. That'll be followed by Newfoundland.
Stage 1 entry is started. Stage 1 entry is shut down. Stage 1 is transonic. Stage 1 landing burn is started. Landing legs have deployed. Of course, I still love you. We have a Falcon 9 on board. Landing operators moving to procedure 11.100 on recovery net.
Yes has been saved.
Flight of the Falcon 9 second stage continues to go nominally. As we've seen, the first stage has successfully landed on the barge in the Atlantic Ocean. On the as we saw, there was a lot of excitement in the SpaceX mission control in Hawthorne when it touched down.
Newfoundland acquisition of signal.
35 seconds to spacecraft separation.
Failed to deploy confirmed.
And we've got it. Spacecraft separation. Dragon has separated from the Falcon 9. Two milestones here today. The